Good morning students. Once again I welcome you to my video lectures on signals and systems. Last class I worked out this problem in the other order. First exponential form, then step wave form. So step wave form was moving and exponential wave form was standing. Now I have reversed the order because for better understanding of convolution integral. Now as usual, this waveform has got two edges. Now first procedure, t is to be replaced by, because we have to convert them to x of tau and h of t minus tau. Now this becomes, now this is x of tau, this is also tau u tau. Now here I will take this separately, okay, and I will form h of t minus tau. So take this between 1 and 2. So here it is 0, 0, whereas here it is e power minus tau. As usual, to create h of t minus tau, take mirror image about this axis and push this waveform by t units. Now if you take the mirror waveform of this, it becomes that means minus 1, minus 2. This is mirror image. So one thing, if this waveform, I hope students have followed, mirror image of this is this. So this is one edge, this is another edge. This will be the leading edge and this will be the trailing edge. Now this is positioned at minus 1, whereas this edge is positioned at minus 2. If you shift the waveform by t units to the left, then this will be called as t minus 1 edge. Now students should be very careful. T minus 1 edge, whereas this edge t minus 2, because t gets added respectively with minus 1 and minus 2. That is why t minus 1, it becomes t minus 1 and t minus 2. For a long distance you push it. Now here I will resketch here, or I will redraw this because I have to carry out the graphical convolution integral. This is x of tau, and here this is t minus 1 edge, this is t minus 2 edge. Actually this will be less than, because this has to be below 1. Now this is proceeding this way. Now from the graph, this is 0 origin, this is tau. From the graph, once again, you know when overlapping starts. So overlapping will not be there in this region because it is 0 here. One of the functions is 0. This function may not be 0, but this function, step function, is 0 for t less than 0. Therefore, mathematical form is 0. Mathematical form means inside the integral 0 means convolution integral is also 0. Therefore, first for t minus 1, you write for t minus 1 less than 0, for t minus 1 less than 0, no overlapping. So transfer 1 to this side, then it becomes t less than 1, no overlap. So this is one region, and in this region yt equals 0. This is first answer. Yt equal to 0, t minus 1. You will have marks for this also. T less than 1 and y of t. Next we have to consider what is going to happen after t greater than or equal to 1. Now I will show this waveform has approached here. T minus 1 edge, t minus 2 edge, t minus 1 edge, t minus 2 edge. Now overlapping starts when t minus 1 crosses, overlapping starts when t minus 1 crosses origin. Is it not? That is t minus 1 greater than or equal to 0. T minus 1 greater than or equal to 0. Next comes the question, how long, what is the width of this waveform? This is t minus 1, this is t minus 2. What is the width? This width is 1 unit, because this is t minus 1, t minus 2. You can do it like this, t minus 2 minus of t minus 1 means t minus 2 minus t plus 1. Therefore, it becomes 1. Minus 1. T minus 2 minus t cancels, minus 2 plus 1 means minus 1. Width. Forget about minus side, 1. Anyhow, width is 1. Now t minus 1 greater than or equal to 0. How long you will push this waveform? So see that, and one point keep it in mind. First I will sketch the waveform here. Now t minus 1, t minus 2. This is t minus 1, this is t minus 2. Now this is overlap. This is overlap. Now t minus 1 proceeds. How long should we take? Because if t minus 1 moves this way, t minus 2 edge is not at all overlapping. Is it not? It is outside this. Therefore, t minus 2 should come to origin. So I will write that as t minus 1, t minus, here 1 is here because this width is 1. So by the time this edge occupies this position, this edge occupies the origin. That is t minus 1 less than 1 or t minus 2 less than 0. T minus 2 less than 0. See, this is the range I have written for leading edge. For the trailing edge, you have to write t minus 2 less than 0. T minus 2 edge comes here. So either you take this or this, combine with this. So here also t less than 2. Here also t less than 2. T less than 2. So combine these two. So t minus 1 greater than or equal to 0 means t greater than or equal to 1. Therefore, if you combine these two, it becomes 1 less than or equal to t less than 2. I hope students have followed by combining either this with this or this with this, 1 and this. So 1 to 2. So between 1 to 2, now this is t minus 1 edge. Therefore, convolution integral y minus t is equal to, don't bother about this edge because this edge is here. It is proceeding this way. For that, there is no overlap. So yt is equal to 0 to t minus 1. Then functional form. This is 1 multiplied with e power minus t minus tau. Because this is a moving waveform, it has to be t minus tau. So now take out t outside because t is a constant. E power minus t integral 0 to t minus 1, 0 to t minus 1, then e power t. Now integrate e power minus t, then e power t tau between 0 to t minus 1. Therefore, e power minus t, e power t minus 1 minus e power 0. That is 1. Therefore, e power e power minus t into e power t e power minus 1 minus e power 0 is e power 0 1 e power minus t. Therefore this t get cancelled, then this becomes 1 by e minus e power minus t. Okay, we are getting the same answer. We are getting this answer in the previous. Now I will write the next stage. This is one of the answers, y of t. Now the waveform has advanced here up to here. So t minus 1 edge has come here and t minus 2 edge. Now during the advancement of waveform, the t minus 1 edge has occupied this position, and t minus 2 edge is coinciding with y axis, that is t minus 2 is coinciding with origin. Now t minus 1 advances further. So t minus 1, I have to first write the rate. T minus 1 greater than or equal to 1. How long should we take? It should go up to infinity. T minus 1 greater than or equal to 1 and t minus 1 less than infinity. T minus 1 less than infinity. If you combine these two, what you will get? You will get t greater than or equal to 2 and t less than, because infinity is there, t less than infinity. So if you combine these two, 2 less than or equal to t less than infinity. This holds good. T minus 2 less than infinity also holds good. T minus 2 less than infinity means once again infinity. Now mathematical form we know, but what should we write for lower limit and upper limit of the integration? So yt is equal to, now this is the advancing waveform. Here its value is 0. Here also its value is 0. So which portion of the waveform is contributing to the overlapping? The portion of the waveform that is contributing to the overlapping is only this. Whereas here it is 0, it is 0. No doubt, of course, this step function has got value, but the other counterpart is having 0 value in this. So this is also 0, this is also 0. So the portion that is contributing to the overlap is only this portion. Therefore, in the interval, one has to write the integration limits as t minus 2, t minus 1. So t minus 2, t minus 1, which is bigger? T minus 1 is bigger than t minus 2, because you are subtracting 2 from t. 1 subtracted from t, which is greater? This is greater. So t minus 1, t minus 2, and here you write the mathematical form e power minus t minus tau into 1 d tau equals, I hope, once again I will repeat, this portion, that is e power minus t minus tau, is contributing to overlap, whereas this side its value is 0, and this waveform has to be advanced towards infinity. Therefore, while writing the limits, you write t minus 2 to t minus 1, t minus 2 to t minus 1, e power minus t minus tau d tau. That is t minus 2 to t minus 1, expand, e power minus t, then e power t. Then take out e power minus t outside, e power minus t, then t minus 2 to t minus 1, e power tau d tau equal to e power minus t, integration same, e power t tau, limit t minus 2, t minus 1 equals e power minus t. Now t minus 1, e power t minus 1 minus e power t minus 2 equal to e power minus t, expand, e power t e power minus 1 minus e power t e power minus 2. So e power t is common and it can be taken outside. When you combine with this, then it becomes e power 0, that is 1. Therefore, answer is 1 by e minus 1 by e square. So it is difficult to plot. This is a constant value. You can't plot this because we know the e value, no doubt. But nobody expects you to write the graph, and this is the answer. Therefore, in this problem, there are three ranges. So t less than 1, one range, 1 and 2, one range, 1 and 2, one range, and between 2 and infinity, another range. So in the next class, I will make it more interesting by taking both the waveforms having two edges. Thank you.